right, and this is section 10.2, part 2. All right, so we talked about significance, and hopefully we were able to break down that definition of a p-value enough for us to start understanding what that p-value means. But we're going to continue discussing what, how do we use that p-value and how do we get the p-value. So we've done the definition. Now we're going to talk about how to calculate and how to interpret. Now, of course, calculating, we're talking about doing this on the TI-84. So we aren't going to try and use by hand methods or tables. If you want to use StatCrunch, you're welcome to. Unless you have a special package, I don't think you can use Excel for this. So I'm just going to focus on how to use the TI-84 and getting this p-value. All right, so like I said, we're going to use our TI-83, 84 calculators to get a p-value. So of course, we're going to hit the stat button, and we're finally going to get to use these tests. So if you remember, we went to stat, over to test, and we saw all these tests when we were going to our intervals. We're going to use our one prop z test because this section is dealing with proportions. Now right now everything's blank because I haven't run one of these, but we've got a couple of things. As you can see, I'm kind of scrolling through. We've got a few different things that we can identify, and what we're going to want to put in, one thing that we're going to want to double check or make sure that we notice is that we have two new things that we didn't see when we did our one prop z int for our confidence interval. We now have this p with a box next to it. That is our null hypothesis. That's actually a p naught. So what is the value? What does our null hypothesis say? Then we are going to put in our information, our x and our n. And then we have our alternative hypothesis. That's what this second to last line, the fourth line down, is our proportion not equal to, less than, or greater than the number for that we put in for p naught. So literally, if we have our null hypothesis and our alternative hypothesis, let's see. This book uses a 1, so let me change that to a 1. There we go. HO and H1. If I say that the proportion, we expect it to be 50%, but for some reason I believe that it's not 50%. But that's not right. Maybe I have a coin, and I just think I don't believe it's landing equally on each side. So it's not 50-50 heads and tails. Then that would be the test I would run. And I could put those numbers in. Now, here's the thing. We have to make sure that we meet certain requirements before we can use the one prop z test. Now, there were a couple of homework assignments, and I believe I've removed them now, where these did not get met, and we had to use binomial probability, which we did not cover. That was section 6.2. We did not go over section 6.2, so I've tried to remove all of those. If you come up with another one where you work through the problem and it says, no, these conditions are not met, and then it asks you to find the probability, then we can't use one prop z test to find that probability. So we've got to make sure that our sample is obtained by a simple random sample, SRS, that's what that's short for, or our data results from a randomized experiment. We've still got to have one of those two things. That was the condition that we had to meet for the one prop z int as well. Then we have to calculate what is n times p naught times 1 minus p naught. So again, this notation, this p sub 0, what that is that is the expected population parameter, or proportion. Too many p's. So whatever it's expected to be, we need that calculation to be greater than or equal to 10. And then thirdly, the sampled values either need to be independent of each other or they need to be able to be treated as such. So remember, if it's without replacement, then it's independent automatically. But we can treat them as much as long as we're taking small samples from a large population. And what we said in the past was that our sample size needed to be no more than, so less than or equal to, 5% of the population size. So our sample size need to be less than or equal to 0.05 times n. And we don't always know the capital N, but we can usually tell if you're talking about adults or, Americans, U.S. America, or adults in America or U.S. adults, whatever, and you've taken a sample of like 2,000 people, well, that's obviously far below 5% of our entire population. I mean, that's probably less than 5% of just Knoxville. So we're usually pretty set with that one, as being able to treat them as independent. All right, so how do we use this p-value? We've defined the p-value. We've seen how we'll be able to get it on the calculator. I'll actually run through some examples. I've got 3 examples for us to work through together, and so we can see how that calculator will do its thing, and then how we can work through the problems. But so we've done that. But then how do we use this p-value? So what are we actually looking for? Well, the p-value, remember, is a probability. And if our p-value is less than our significance level, so if it's small, that's usually how we write it. If our p-value is less than alpha, so if that probability is small, I guess small enough, then we reject the null hypothesis. We have the evidence that we need. And so I like to go through a series, like a whole list of ideas that all connect to what happens if the p-value is less than our significance level. So I want to write those out for you and kind of make a chart with what happens when the p-value is less than alpha versus when our p-value is greater than alpha. All right, so we're going to look at what does it mean when our p-value, which is the probability of getting our particular sample statistic, getting something that extreme or more extreme, that p-value that our calculator gives us, what happens when that is less than our significance level? And if you recall, our significance level is the cutoff that we choose, or if we're working on a problem, it may be given to us, but it's the cutoff to say we're okay with our sample statistics being this far away, but no further. So that's our probability that we're comparing it with. So what does it mean when p is less than alpha? Well, first of all, just what does that symbol, what do those symbols change to? That means that the p-value is less than the significance level. So that's literally just the words for those symbols. And that's important because we need to be able to recognize what that symbol means, and so that we can make the correct decision. The next thing that leads us to understand is that the chances of getting a sample value this far away from what is expected, which is our null hypothesis, is unlikely. We've found an unusual sample. Now, does that mean that we know samples vary? Does that mean we just happened to get a sample that was really far away from what we expected it to be? Or do we believe that the null hypothesis is wrong? That's why we want to set our significance level appropriately. All right, so once we've determined that, this is a very small chance of getting this sample if the null hypothesis is true. That means our sample statistic is unusual enough for us to start doubting the null hypothesis. So we now have the evidence that we're looking for. In fact, not just evidence, but we have sufficient evidence. So that's usually the word we use is sufficient or insufficient. If our p-value is less than alpha, then we have sufficient evidence to suggest that the alternative hypothesis is true and the null hypothesis is false. All right, and then our conclusion, and we'll get some practice with this. Like I said, I've got 3 examples for us to go through in parts 3, 4, and 5 of the series for 10.2, and we'll see this. We'll say something along the lines of, there is sufficient evidence at the 5% level of significance to suggest that the coin lands on heads more than tails, or whatever our context from the problem is. That context is given in the actual problem, and we'll just fill that in as needed. All right, so that's what happens if p is less than alpha. Well, p is either less than alpha or greater than alpha. I guess technically we do need to have, it would be less than or equal. So let me draw that line under there. The only reason that we don't always worry with that part is because, remember, this alpha that we get, or the p-value that we get, is an area under a normal curve, or this bell-shaped curve. And we've never seen numbers where those are actually nice. But technically, if we did get a p-value that was exactly equal to our significance level, then we would still reject the null. All right, and now what if our p-value is bigger than alpha? Well, then, again, just putting that into words instead of symbols, the p-value is greater than the significance level, which means that the chances of getting a sample value this far away from what is expected is not unusual or unlikely. It's just, that's where we come in and say, oh, well, samples vary. It's not what we expected, but it's not far enough away for us to be that concerned. In fact, our sample statistic is not unusual enough to cause doubt. So we're thinking, well, again, I'm okay with this. This isn't that bad. Then we would say we have insufficient evidence at, whoops. Oh well. Apparently I drew with my white pen a little bit while I was setting this up, so that won't go away now. Anyway, we have insufficient evidence, which means that the null hypothesis is true and the alternative hypothesis is false. So that semicolon there is just kind of a pause in our thought, and we've got a connected sentence going with it. So we have insufficient evidence. That's the main thing. If we don't have sufficient evidence, then we, just like if a jury doesn't feel that the prosecutor presented sufficient evidence, then they are not going to say that they think the defendant is guilty. The null hypothesis is true, the alternative hypothesis is false. And then our conclusion in that case would sound something along the lines of this. There is insufficient evidence at the, now I changed it up here. So the reason I changed this was simply so you could see a couple of different possibilities. So we could use the 5% level of significance, or we could say alpha equal 0.01 level of significance. Those are just different ways of saying the same thing. So there is insufficient evidence at the alpha equal 0.01 level of significance to suggest, and then fill in the blank, whatever context from the problem is. So this is kind of how I think through coming up with my decision, going from the p-value to making the decision to stating the conclusion. All right, in the next video, we'll look at some examples.